Okay, so welcome to Story Squad. We are a really cool app you got set up on here. Basically, children submit written pages of like responses to a story, uh, and it's like a weekly system. And we kind of put them in matchups against each other, and they vote on whose was, better. And it's sort of an engaging way to get children to write and get more interested in being creative. So I'm going to walk you through the back end really quickly. This is going to be the answer to most of your questions for the back end. This is the Swagger documentation. We don't really cover it in the Lambda curriculum, at least not when I went through. I don't know if you guys went over it at all, but basically every single endpoint right here, so it's base URL / game / squad with the parameter child ID. Every endpoint is thoroughly documented with any parameters, and every single response that's possible for that endpoint. So you'll see it has a 200, and it shows you exactly what the response data is going to look like. A 400, exactly what the response data is going to look like. And these are all really up to date. I've been very thorough and meticulous, making sure that all of these endpoints have been up to date so that you coming in know exactly like what to expect out of them. So it should be really easy. Any questions you have about the backend should be answered right here in this Swagger documentation. So let me go ahead and just go through a bit of the code. A few things I did do that were slightly different. I sort of abstracted all of the basic database operations into these functions here. So it's kind of weird, kind of hard to wrap your head around at first, but when you see it a few times, it sort of makes sense. So right here, you'll see we're calling get all, which is this function over here, and here we're trying to get all of the children. So gets a list of children from the database. So this mod function right here, get all, doesn't have any parameters in it. So what happens is this query gets passed into this function, and it asynchronously runs this query with any arguments you pass in. So you see here, we're not passing in any arguments. Down here on the get by ID, we are passing in an ID. So down here, you'll see get by ID, this ... args. This ID will be rested, the rest versus spread operator will be rested into this arguments array. And then the arguments array gets spread right back into the query parameters. So sort of a little weird how it's set up, but if you take a look at it, it should be a lot easier to use. It just makes your responses from endpoints more consistent, as well as provides a quick way to handle errors, right? Like these 5, 6, 7 functions, 6 functions right here, are used across multiple endpoints throughout the project. So very consistent error messages, very consistent response codes, and just very easy to use. Here is kind of the bread and butter of the app, at least for the backend. It's the file upload handler. So all of the child submissions, whether they be written or drawn, are stored in an Amazon S3 bucket. I'm sure your TPL can go over how to sort of connect to those a little more in depth with you. But so basically, it's a large asynchronous middleware, and that's what this is. It's a middleware, right? So it's a middleware that you can put on any endpoint that requires file upload. The only prerequisite is that the images are uploaded as form data in the request body. And if you look on the front end, there's some really good examples of that, of how the image upload is handled on the front end. So basically, you can expect it if the file upload field in the form is called files, right? Then basically it goes through all of this. It allows for multiple uploads with multiple file names and or multiple different file fields and multiple different files in one field. And you'll also see some examples of that in the render writing sub component on the front end. So basically at the end, it just puts the files and then the request body just right back into the request body. So it just parses it into the request body as if it was just normal request body data. This is super cool middleware. I recommend you take a little bit of a deeper look into it. I also have a blog post where I kind of explain it a little more in depth. I'm going to stick a link to the README, or stick a link to that blog post in the README, just for a little more in-depth explanation of this file upload middleware. Another thing, a lot of our database queries are transactional, meaning it requires multiple different queries or requests to run and multiple conditions to be met. And if anything goes wrong, it acts as if nothing ever happened, right? So if we're getting, so this isn't exactly the example I want, but so basically right here is it'll return a list of squads, and this will return a list of members. If anything goes wrong in here, it'll pretend these other transactions never happened. So this is a transaction object. It's just a specific instance of the next client. So instead of DB, you're running your queries on the little TRX object that's passed into this callback function. There's really good documentation for transactions on the next website. Definitely recommend looking through it because it's very helpful, and it's used a lot throughout the site, especially in the cluster generation, which you might have to talk to data science a little bit about. So basically you can see here, there's a lot of adding things to tables. So if any of these functions fail, so if it adds the squad, but it somehow can't add the member, everything gets canceled and it's like nothing ever happened. So this squad will be deleted, and if the members fail and the teams fail, this squad will just be deleted from the database as if it was never added. So it's a really cool feature. It helps keep your data intact, and it's just a kind of a good programming pattern to learn transactional queries. Last thing, we are kind of the liaison between the front end and the data science API. So the data science API parses out some of this text in the submissions, gives us like a complexity score, as well as a few other metrics letting us know if it's a sensitive topic, if it should be marked as potentially sensitive or inappropriate. Data science lets us know these things, as well as they return these little like nice line graphs for us based on a child's data. So we do have all these data science queries kind of built in here. They are all mocked for testing. Other than that, there's not a whole lot more to the back end that you really can't figure out just by digging through some documentation and having a good time with it. And I really hope you enjoy this app we built out for you. Let me kick it off to the front end.